A star has vanished, not died, not exploded, not collapsed, vanished. A cosmic giant, burning a million times brighter than our sun, monitored for more than 10 years and expected to explode in one of the most spectacular supernovas in recent history, simply disappeared. No warning, no fading, no debris, nothing. One moment, this massive blue supergiant was there, violent, unstable, shaking with nuclear fury. The next moment, gone. A silent blackout in a distant galaxy. And what scientists discovered after this disappearance is far more disturbing than any explosion could ever be. A star that should have died loudly, died quietly. A star that should have left behind chaos, left only emptiness. A star that should have been impossible to miss, slipped away unnoticed. Tonight, we investigate the most mysterious celestial disappearance ever recorded, and the terrifying possibility that this may happen again, closer to home than we think. Welcome to Universal Mysteries. The missing star was located in the Kinman Dwarf Galaxy, a faint, distant galaxy roughly 75 million light-years from Earth. Astronomers have been observing this galaxy for decades, but one object within it stood out: a luminous blue variable, or LBV. LBVs are the drama queens of the universe. Massive, chaotic, unstable, burning millions of times brighter than our sun. Their entire existence is a cosmic meltdown. A normal star, like our sun, burns calmly for billions of years. A luminous blue variable burns violently and unpredictably, constantly shedding mass, releasing powerful eruptions, and trembling with instability. LBVs are rare. Astronomers estimate there may be fewer than a dozen in our entire galaxy. And they almost always end their life in a massive supernova. That's why the disappearance of this one became one of the greatest cosmic mysteries of our generation. Back in 2009, this star was bright, extremely bright. Too bright for its own good. It was so luminous that even though the Kinman Dwarf Galaxy is too far away to resolve individual stars, scientists could identify this one solely through its signature, a distinctive set of wavelengths produced only by LBVs. But after 2009, something changed. When astronomers returned in 2019 and pointed the European Southern Observatory's Very Large Telescope, one of the most powerful on Earth, at the same location. Nothing, none of the spectral fingerprints were present. No star, no LBV signature. Just darkness. It wasn't dim, it wasn't hiding, it wasn't behind dust, it was gone. This discovery sent shockwaves across observatories worldwide. Because LBVs don't just vanish. They are too massive, too bright, too explosive. Scientists immediately began searching for an explanation, and the first theory they considered was surprisingly simple. Maybe the star had collapsed into a black hole. When a star collapses into a black hole without a supernova, it's called a failed supernova. A dramatic name for a dramatic process. But even a failed supernova must produce something. A burst of neutrinos, a change in gravitational waves, a sudden flicker of X-rays. But nothing like that was observed. Worse, a new black hole should leave behind a mark. Black holes bend light, distort space, and create gravitational lensing. But the region around the missing star showed no gravitational distortions at all. That means if a black hole formed, it is so unusual that it behaves unlike any other black hole ever discovered. A ghost black hole, silent, invisible, undetectable. If such objects exist, they may be traveling across the universe right now without us noticing, consuming stars in total silence. This possibility terrified researchers, but the alternative was even worse. What if the star did explode, but the explosion was somehow hidden? Supernovas are the loudest events in the universe. They emit deadly radiation, shockwaves, and sometimes jets moving close to the speed of light. They shine so brightly they can be seen across galaxies. But scientists considered an exotic scenario. What if the supernova was buried behind an enormous dust cloud? If the dust was thick enough, maybe the light never escaped. But the physics refused to cooperate. Even behind dust, a supernova produces heat, infrared radiation, gamma rays, neutrinos, X-rays, and weeks of glowing after effects. Yet telescopes across multiple wavelengths, visible light, infrared, radio, ultraviolet, detected none. Not reduced signals, not faint signals, none. The LBV did not explode. It did not collapse violently. Instead, it vanished with surgical precision. This led researchers to examine the star's last known behavior more closely. Data from 2001 to 2009 revealed several violent eruptions, typical for a dying LBV, but none strong enough to indicate imminent destruction. LBVs sometimes experience outbursts, where they blow off large amounts of mass, temporarily getting brighter or dimmer. Eta Carina, the most famous LBV in our own galaxy, nearly exploded in the 1840s, releasing the energy of a supernova without actually dying. It survived, but the explosion created massive clouds of gas that still blow today. This comparison offered a clue. Perhaps the missing star had shed so much mass during its final outburst that it became dramatically less luminous. But that still didn't explain the disappearance. If the star had simply dimmed, astronomers would still detect something, even a smaller star. A tiny signature, a faint spectrum, a weak glow, but the observations showed nothing at all. It wasn't dimmer, it wasn't weakened, it wasn't hidden, it was erased. This is the moment scientists realized they were no longer dealing with normal stellar evolution. Something stranger was happening. One theoretical possibility is that the star experienced a rare phenomenon known as pair instability collapse. This occurs when temperatures in the star's core get so high that gamma rays convert into matter-antimatter pairs. This destabilizes the star and can cause it to collapse directly without exploding. But this process still produces radiation and leaves behind a black hole, again, something detectable. And still, the region is empty. Another possibility scientists explored was a merger event. What if the star merged with something we couldn't see? If a binary companion, another star or a black hole, spiraled into the LBV, it could create gravitational chaos, mass ejection, collapse, unpredictable emissions. But mergers create shocks, flares, and heat. And once again, none were seen. Everything kept leading to the same impossible conclusion. The star did not die. It did not collapse. It did not explode. It simply disappeared. This led astronomers into far more exotic theories they almost never discuss publicly. Some physicists have suggested that in extremely rare circumstances, a region of spacetime can undergo metric fluctuation, where the geometry of space itself changes. If such a fluctuation passed through the star, it could destabilize the internal core pressure and cause a silent implosion. Others have proposed a hypothesis linked to primordial black holes, ancient relics from the Big Bang that could drift across galaxies. If one of these tiny but incredibly dense objects passed through the LBV, it could collapse the star from the inside without an explosion. There is also the dark matter hypothesis. If a clump of dark matter with unusual density passed through the star's core, it could absorb energy, destabilize fusion, and cause collapse. But once again, all of these theories still predict radiation, heat, gravitational ripples, or at least a detectable residue. Yet the region where the star once existed is cold, dark, empty, a cosmic graveyard without a grave. Some astronomers now suspect this may not be an isolated incident. Across several galaxies, there are reports of stars exhibiting sudden changes in brightness that don't match any known patterns. Some stars dim too quickly. Some radiate strange pulses. Some lose mass violently and without explanation. It's possible these are early warning signs, stars beginning to behave like the one that vanished. And if that's true, something in the universe is affecting them. Something powerful, something invisible, something we don't understand. One thing is certain. Stars don't just disappear. Not unless the universe itself rewrites the rules. The deeper scientists looked into the mystery, the stranger it became. Because even in the most extreme cosmic events, supernovas, gamma-ray bursts, stellar implosions, the universe always leaves fingerprints. Heat, light, radiation, gravitational waves, shocks in nearby stars, clouds of debris, but this disappearance left nothing. No fingerprints, no shadow, no footprint in spacetime. It was as if the universe erased a line from its own script. When astronomers realized what they were seeing, the first reaction was disbelief. Then panic, then silence. In leaked private discussions, several researchers admitted they were afraid to publish early reports. Not because the data was unclear, but because the implications were overwhelming. One wrote, "This is the first time in my career that I have no theoretical framework at all." Another stated, "Something happened that should be physically impossible. To understand why this disappearance is so devastating to science, we have to look at how stars normally live and die. Massive stars follow predictable lives. They are born from collapsing clouds of gas. They ignite nuclear fusion. They shine for millions of years. They grow unsteady. They shed mass. Then they explode, spectacularly. After that, they leave behind a neutron star, or a black hole, or at the very least, a glowing nebula of debris. But this star left none of those. It does not fit into any known category of stellar evolution. So astronomers expanded their investigation to unprecedented depths, using the most sophisticated tools we have. 1. Hubble Space Telescope. Hubble scanned the region repeatedly. No trace. Even faint remnants of dying stars appear in Hubble imagery, but here, nothing. 2. ESO's Very Large Telescope. The same instrument that first detected the star returned to study the region. It confirmed total absence. 3. Infrared surveys. Infrared detects heat even when dust blocks light. The region was cold. 4. Ultraviolet surveys. A collapsing star emits intense UV radiation. There was none. 5. Radio telescopes. Radio waves trace gas debris and shockwaves. The region was silent. 6. X-ray observatories. New black holes emit specific X-ray signatures. No emissions detected. Every possible channel was investigated, and every channel said the same thing. The star is gone. The space around it is unchanged. No natural process can explain this. This forced scientists to push into even stranger realms of theoretical physics. And that's where the truly disturbing possibilities began. Possibility 1. A primordial black hole hit the star. Primordial black holes are hypothetical objects from the earliest moments of the universe, tiny, dense, and nearly impossible to detect. Some may be no bigger than a mountain, but with the mass of a planet. If one passed through the star, it could have eaten the core from the inside, causing a collapse with no outward explosion. This would result in no light, no debris, no shockwave. The perfect silent death. But if that's true, then primordial black holes could be drifting through galaxies right now, including the Milky Way, invisible and deadly. This idea horrified astronomers. Possibility 2. The star was pulled into a higher dimension. It sounds like science fiction, but it is based on real theories from string theory and Brane cosmology. If our universe is just one sheet inside a higher dimensional space, then under the right gravitational stress, matter could be pulled out of our reality entirely. If that happened to the star, it would disappear instantly, leaving no trace, exactly like the observations show. Some models predict that regions with extremely high mass become unstable in higher dimensional geometry. An LBV at the edge of collapse would be the perfect candidate for such a bizarre transition. This theory is fringe, but the disappearance matches it perfectly. Possibility 3. The star was destroyed by dark matter. Dark matter makes up 85% of the matter in the universe, but we don't know what it is. It doesn't emit light, doesn't absorb light, doesn't interact with normal matter, except through gravity, but some researchers believe dark matter may have hotspots, dense concentrations that can destabilize stars. If a dark matter cloud passed through the LBV, it could have collapsed the core, extinguished fusion, caused silent implosion, absorbed energy, left no debris. This process has been proposed in several scientific papers as a possible trigger for silent stellar deaths. But we would need a very dense dark matter cluster to do this, and detecting such a thing is nearly impossible. Possibility 4. The star became a direct collapse black hole. This is one of the most dramatic ideas, and also one of the most realistic. A direct collapse black hole is a rare event where a star's core collapses inward so violently and so rapidly that the outer layers don't have time to explode outward. The star simply implodes. No supernova, no bright flash, just a sudden gravitational collapse. The problem is, direct collapse black holes still produce faint infrared signals and leave behind altered gravitational environments. But here, none were detected. So if this was a direct collapse black hole, it behaved in a way no black hole ever has. Something new, something unseen, something dangerous. Possibility 5. Stellar cannibalism. Stars sometimes die because something else kills them. If an invisible companion, possibly a black hole or neutron star, orbited near the LBV, it could have drained its mass, stripped away its outer layers, destroyed the core, consumed the star entirely. This is known as stellar cannibalism. Binary death systems are responsible for many of the strangest cosmic events we observe. But even cannibalism leaves signs, gas streams, bright flares, high energy emissions. Yet here, there is complete silence. A perfect crime in space. Possibility 6. A quantum collapse event. Some physicists propose that under extreme conditions, quantum fluctuations could collapse matter instantaneously, destroying the internal structure of atoms themselves. This kind of collapse would erase matter almost instantly. It sounds impossible, but so does the disappearance we're trying to explain. quantum collapse could turn the entire star into a tiny, dense remnant, too small to detect. If true, this would be one of the rarest events in the universe, and possibly the beginning of a new class of stellar phenomena. Possibility 7. A cosmic event horizon shift. Some thinkers believe that the universe is not static, that spacetime itself can shift unevenly. If the star crossed into a region where spacetime geometry changed abruptly, possibly due to massive unseen structures, it might fall beyond our ability to observe it. This could create what looks like a disappearance, even though the star still exists, just beyond a new cosmic horizon. This is among the most extreme ideas, but astrophysicists have not ruled it out. Meanwhile, astronomers around the world continue scanning the Kinman dwarf galaxy. Every telescope that can be pointed in its direction has been pointed. Every wavelength is being examined. Every theoretical idea is being tested. The result? The star remains gone. The region remains cold. The galaxy remains unchanged. It is as if nature itself buried the evidence. Some scientists now believe we may have witnessed something entirely new, a kind of event rarely seen in the universe, perhaps happening silently in distant galaxies without our knowledge. Others fear this is the first sign of a larger cosmic pattern, a change in how massive stars die. And a few whisper the most unsettling possibility of all. What if something out there is causing these disappearances? A force, a structure, a phenomenon, or even an object, something powerful enough to erase a star. Something silent, something precise, something unknown, and if it happened once, it can happen again. As telescopes continue searching, the question grows louder. What can erase a star from existence? A ghost black hole? A dark matter weapon? A dimensional rupture? A primordial anomaly? A cosmic predator? No one knows, but one truth remains. Tonight, a star vanished. Tomorrow, another might follow. Stay curious, because the universe is not just bigger than we imagine. It's stranger, and far more mysterious.